let's say you have the square root of 3 times the square root of 3. I'm going to teach you the most basic principle of multiplying and dividing radicals that I can really teach you, and that is this right here. When you have a radical, like a square root or a cube root or something, and you're multiplying it by another radical, all you do is you write another radical sign down and you multiply the insides. 3 times 3 is 9. Just make sure that whatever you multiply here, it has to stay underneath a new radical, because after all, that's what you're dealing with in the first place. So you could write that down as your answer, but we know that we should always check to see if the radical is fully simplified. In this case, if you haven't already memorized it, 9 is equal to 3 times 3. These are square roots, so I'm going to look for pairs of 2, which I've found. And so I can pull this 3 out of the radical and write it down. So the answer to this is, in the end, 3. If you were to go in your calculator, take the square root of 3, and take another square root of 3 and multiply them together, you would get 3. Okay? What if you had square root of 2 times square root of 8? Okay? I want you to use the principle we just talked about, which is very simple. You write another radical sign down, and you take what's underneath and you multiply them together. 2 times 8 is 16, so you put that underneath a new radical. Okay? Again, you need to ask yourself, is this fully simplified? 16 is equal to 4 times 4. These are square roots, so I'm looking for pairs. So, if you haven't already memorized it, the square root of 16 is equal to 4. And that's the answer to that problem. And you'll find that as you work these problems, you'll start to memorize things. Square root of 9 is 3, square root of 16 is 4, square root of 64 is 8. You'll get to memorize those. But for now, I'm doing it kind of a long way to reinforce things. Okay? So that's really the basic idea. And that's all we're going to do in this section. We're just going to do more and more complicated problems, but we're going to be multiplying radicals the whole time. What if you had the cubed root of 8 times the cubed root of 8? Well, just like I told you, you just write down a new symbol, cubed root. 8 times 8 is 64, so I write that down inside the radical. And then again, I can't stop here. I need to try to simplify. 64 is 8 times 8. 8 is 2 times 4. And 4 is 2 times 2. I'm going to have the same thing over here. 2 times 4 gives me 8. And under the 4, 2 times 2 gives me the 4. These are cubed roots. Okay, cubed roots. So I'm going to be looking for pairs underneath the dotted line. This is included, everything here is included because that's the bottom of the tree. I'm looking for pairs of 3. Here's a pair of 3. And looky here, here's a pair of 3. Okay? So, 1, 2 comes out here. Okay? And another 2 comes out from this pair of 3. 2 times 2 just gives me 4. There's no radical left over. There's no cubed root anywhere because I've used everything in my tree and I've found pairs of 3. So just like in the previous section, that's all I'm trying to do, and the answer is 4. If you were to take this and put it in your calculator, it would give you exactly 4. Okay? Let's work with some variables here to mix things up. If I have the square root of x to the third power times the square root of x to the third power, okay, that's going to be equal to the square root, and I'm going to be multiplying these two things together. So I'm going to write it out in explicit detail so no one gets lost here. It's going to be x cubed inside times x cubed, right? But remember, okay, and we're going to continue right down here. Remember, when you're multiplying variables with an exponent, all you do is you add the exponents. Okay? So you write the x down and you add the exponents. If that rule of algebra seems a little foreign to you, then you can go back to my previous video on beginning algebra and we'll have all kinds of examples worked out there. But you're going to be left with this. Okay? Again, you can't just stop here. You need to press on and simplify. So, x to the 6th power is, if you think about it, x times x times x times x times x times x. 1, 2, 3, 4, 5, 6. That's the definition of x to the 6th power. It's x multiplied by itself 6 times. Okay? And again, I'm looking for, because this is a square root, I'm looking for pairs of 2. So there's a pair of 2, there's a pair of 2, there's a pair of 2. Okay? So this x comes out, this x comes out of the radical, this x comes out of the radical, and then x times x times x is just x to the 3rd power. So it took a little bit of work to get there, but basically it's the same thing. You multiply what's inside, which is what we did, and then we just used algebra to figure out that this is what resulted, and we simplified this and arrived at the final answer, which is over here. Okay. Now let's do a very important class of problems here. What if you had negative 5 times the square root of 6 multiplied by, or to make it even more clear, instead of using the dots, I'll just put parentheses around here, and I'll start a new one and say 4 times the square root of 3. How are we going to simplify that? Because in the previous problems, we just had a radical and a radical, we multiplied them, and we figured out how to do that. But here I've got some coefficients. Okay? What you do here is you treat each thing individually. You have a negative 5 and a 4. You multiply those things together. It's negative 20. 5 times 4 is 20. Negative times positive gives me negative. And then separately, I multiply the radicals. So I write my radical down, and I multiply the inside. 6 times 3 is 18. And that's what stays under the radical. Okay? And really, if this confuses you, you can think of it this way. Do you know how to multiply 3x times, or to make it look the same, we'll just put parentheses around it, times 2x. Okay? Do we know how to do that? Well, if you learn that from Algebra 1, you take the coefficients, 3 times 2, which is 6, and you take the x's, x times x gives you x squared. We're doing the same thing here. Negative 5 times 4 gives me negative 20, and then square root of 6 times square root of 3 gives me square root of 18, because when you multiply radicals, you multiply what's inside and put it over there. Okay? But don't forget, though, that even though we've gotten this far, that's not the final answer, because this is a radical. It's 9 times 2, and 9 is 3 times 3. We're looking for pairs. There's my pair. So 3 is going to come out. So to continue writing this logically, I'm going to have negative 20 times 3, which is what's come out of the radical, times the square root of 2, which is just what's left over here. And don't forget, like I just did, that you have a negative sign right here, because negative was up here at the top. And then finally what you're going to have is 20 times 3 gives me negative 60 with the negative sign, times the square root of 2. That's the answer to the problem. So when you have multiple things hanging out in front of your radicals and you're multiplying them together, that's okay. Just multiply them together too. And everything will make sense. And I'm trying to teach you as we go here that these rules of radicals, you've learned some of them already as you learned some of the other topics we covered in my other course. We're just building on them here. So moving along here to something a little more complicated, 8x times 2x cubed times y. Okay? And we want to multiply that. Well, we got a radical times a radical, so let's draw a big old radical here, just to give us some room. And we multiply the insides. 8 times 2 gives me 16. X times x cubed. Remember, when you multiply x times x with another exponent, you just add the exponent. So that's x to the 4th power, because 3 plus 1 gives me 4. When you multiply x times x cubed, you add the exponent to give you x to the 4th power. And then y is just left over. It's not really multiplied by anything but the rest of the stuff there, so y just hangs out in there. So here is really the answer to the problem, but what remains for us to do is to simplify this answer. So let's do that. This is equal to 16 times x to the 4th times y. Okay? 16 is just 4 times 4, right? X to the 4th, I'm going to show you something a little bit here, is just x squared times x squared. And you can see here that this is the bottom of the tree. Okay? Now, for this x to the 4th term, I could have written x times x times x times x. I could have written x 4 times. That would certainly be fine. But in the end, I'm just going to circle pairs of x, and I'm going to get 2 pairs of x. It's going to give me the same answer. X to the 4th is equal to x squared times x squared, because when you multiply these back, you add these exponents, and you get back what you started with there. So, I'm looking for pairs of 2. I found one, and I found one. Okay? This 4 is going to come out. One of the x squareds is going to come out because there's a pair there. And underneath the radical is going to be y, because that's going to be what I have left over. There's nothing else there. And this would be your answer. So it's the same thing. You multiply the insides, and then you just use algebra to kind of figure things out and kind of simplify things. Okay. What if we have, here's one that looks a little bit fun. What if we have, under parentheses, square root of 2 minus square root of x, all this stuff raised to the 2nd power. Now that looks a little different than what we've been doing so far. But just use a little bit of logic and you'll realize that this is just equal to square root of 2 minus square root of x times itself, because it's squared. Okay, so this is equal to this. Now we can work with that, because remember, from beginning algebra, we use what we call FOIL. First term, outside, inside, last. And this refers to the order in which you multiply the stuff to get what you want in the end. And the whole FOIL concept was covered in a previous course. I'm assuming that you understand how to do this. If you don't, you can review that. Let's go ahead and apply FOIL right here. We're going to do the first terms first. So square root of 2 times square root of 2. Square root of 2 times square root of 2. The outside term, which is going to be this term times this term, okay, is the square root of 2 times the negative square root of x. Square root of 2 times negative square root of x. You've got to carry your negative signs through. Okay. For the last 2 terms, I'm going to continue writing down here. Inside is negative square root of x times square root of 2, negative square root of x times square root of 2. Okay. And then the last term is going to be this times this. I've got a negative square root of x times negative square root of x. Negative square root of x times negative square root of x. And you notice here that I did not really skip any steps. I did not try to do any multiplication in my head. I mean, I could have tried to simplify this term, for instance, just outside of my head. I could certainly do that, but I think it's a good example to show that I write everything down in its most beautiful expanded form, and then we go on and try to simplify it. That way you don't make any mistakes. So let's do that. We're going to continue on over here. Okay? Square root of 2 times square root of 2 is square root of 2 times 2 is 4. So I'm going to leave it like that. This term, I've got a negative something times positive something, so I know I'm going to have a minus sign. Square root of 2. Square root of 2 times square root of x is going to be the square root of 2x, right? Because I just multiply what's underneath the radical. 2 times x gives me 2x. Negative sign is because it's negative. Then I've got this term. Again, negative times positive is going to be negative. Square root of x times square root of 2. I multiply what's underneath. That's the square root of 2x hanging out right there. Finally, my last term, negative times negative gives me positive, so I'll put a plus sign here. And square root of x times square root of x is square root of x times x. And this is a good example. I know that this is going to be x squared in the end. X times x is x squared, but I'm writing everything out so I don't make any mistakes. Okay. Square root of 4, you should know by now, is just 2. Because 2 times 2 gives me 4. Negative square root of 2x minus square root of 2x is going to be negative 2 times the square root of 2x. Okay? And you can kind of think of that as, this is like a term, okay, like x. And this is another term, like x. And so I'm subtracting two common terms here. So I look at this coefficient, which is negative 1. This is also a negative 1. Negative 1 minus 1 gives me negative 2, and I've got to keep that commonality here, which is like my pencils in my other example, pencils or apples or whatever, and I've got to drag that along for good measure. Okay, so I've got this minus this gives me this, and then finally, in the end, this is going to be square root of x squared. Okay, so to finally simplify, this is going to give me 2 minus 2 square root 2x. Square root of x squared is going to be x, because x times x gives me x squared. If that doesn't sound right to you, you can also do it this way. You could put x times x down here, look for, if we're trying to do this, look for a pair of 2. I found it, take the x, pull it out, that's what you get. But I just happen to know that the square root of x squared is x, because the square root and the square kind of cancel each other out, so I'm left with what's left inside. So that's what you have. And that's the answer. You can't do anything more with this because there's no common term anywhere. I've got an x, a square root of 2x, and just a constant, and there's nothing else to do there, so I just stop and say, that's my answer. So even though that problem looked quite a bit different than the others in the beginning, you just kind of plow through it and go from there. Let's work on some divisions. We'll do a few problems of division and that'll be it. What if we have square root of 12x to the cubed, or to the third power, divided by square root of 27x. Now, what do we do here? I told you that when you multiply radicals, all you do is you write another radical next to it, and then you multiply the insides. Here's the fundamental rule for division of radicals. When you have a radical divided by another radical, you draw a big radical, which is the same thing we did before, and then you just divide the insides. Okay? So I'm going to have inside 12x cubed over 27x. Now that's pretty cool. That's pretty symmetrical if you think about it, because if you have like square root of x times square root of 3x, you just write a radical and you multiply these. So you got x times 3x in there. Here, you just draw another big radical and then you divide what's there. So it's very easy to remember when you know how to do this stuff. Okay? Now, what do we do next? Okay? Well, you've got this stuff in here, okay, and you can try to simplify that using your known rules of algebra, okay? And the way you do that is you have an x on the bottom and you have an x cubed on the top. So if you remember back from Algebra 1, when you have something like that, I can strike out that x, and I can strike out that 3 and just write a 2 there, because I'm dividing these so I can subtract these exponents. So 3 minus 1 gives me 2. I'm going to be left with an x squared on the top. Okay? There's really two ways to think about how to do that. You can just say, okay, well, this is an exponent of 3, this is an exponent of 1, so I subtract them, and I get x to the second power. Or, equivalently, you can just say, okay, well, I can strike that, and that's 1, and I'm going to take that exponent away, and I'm going to, since I've sucked that one up and I've thrown it away, I'm going to subtract 1 from the exponent at the top, and that's what I'm going to get. Okay? Likewise, you can simplify this, and you can, remembering back from how to simplify fractions, you can work on that. So you can try to figure out what will go into each of these numbers an even number of times. And the number 3, off the top of my head, will do that. How many times does 3 go into 12? 3 goes into 12 4 times, so I write a 4 there. How many times will 3 go into 27? It goes 9 times. Okay, so I've simplified that fraction. Okay, so we can write my big radical again. What I'm left with is 4x squared on the top divided by 9. That's what I'm left with. Okay, and then in the end, what you're going to end up doing here is you're going to split this radical back up so that you have, the easiest way to do it really, is to split it back up like this, because it works in reverse. If you have something in the radical there, you can break that radical back up and put a radical on the top and a radical on the bottom and make it the same way it was in the beginning. Okay? For the top radical, I'm going to skip a few steps here because I think you're far enough along to understand this. Square root of 4x squared, I'm going to just write it down as 2x. That's the answer to the top. The square root of 9 is just 3. And that's the answer. And if you're confused or wondering why this has worked out, it's because the square root of 4 is 2. The square root of x squared is x. If you think about it, 2 times 2 gives me 4. X times x gives me x squared, so that checks out. 3 times 3 gives me 9. You could also do the trees and all that stuff, and that'll work out just fine. You'll see this is the answer. So what we did is we extended the radical, we simplified underneath, we put the radicals back on top and bottom, which is perfectly fine, and then we found the answer. I also want to point out to you that you don't have to do it this way. I'm trying to teach you the rules here, so I'm kind of going a roundabout way. What you could have done was you could have done the tree, drawn a big tree and simplified this. You could have drawn another tree, a separate tree for this, and simplified it. And then you would have seen that you'd have a fraction, something on top, something on bottom, and you would simplify that fraction and you would get this. Okay? Okay. Let's do something that changes gears a little bit. Okay. What if I have 1 divided by the square root of 3? Okay. I've already told you that mathematicians don't like to have square roots in the denominator, so to get rid of this, I'm going to multiply top and bottom by the square root of 3. Okay, because really what you're doing here, this quantity is equal to just 1. Anything over itself is 1. So I haven't changed the problem by multiplying by 1. I've just written the number 1 in this funky manner that's going to help me. Okay. So on the top, I've got 1 times the square root of 3, which is the square root of 3. On the bottom, I've got square root of 3 times square root of 3, which is square root of 3 times 3 gives me 9. Okay. Now, on the top, square root of 3 you really can't simplify anymore. But on the bottom, square root of 9 is 3. So, you can see that when you do this, that you've got something that doesn't have a radical on the bottom. Okay? Now, what if you had something a little bit more interesting, like 3 over square root of 3 minus 1? And you wanted to simplify that. Again, you don't like fractions on the bottom, or rather you don't like radicals on the bottom. Okay? So what you want to do is you want to simplify that. And you want to multiply top and bottom by something. Okay? And let me show you, at first I'm going to show you what not to multiply by. Okay? And I'm going to show you why. Your first inclination would be, go ahead and multiply by square root of 3 minus 1. Okay? That's wrong. Wrong, wrong, wrong. It's okay to do it, because this quantity is equal to 1. Anything over itself is 1. It's fine to do it. It's just not going to simplify anything for you. Let me show you why. The reason you multiplied by this term up here was to give you a perfect square in the bottom so that you could get rid of this square root and you get a nice number here. Let's go ahead and multiply this stuff on the bottom right here. Square root of 3 minus 1, square root of 3 minus 1. I'm just going to quickly go through the denominator and show you why. Square root of 3 times square root of 3 is the square root of 3 times 3 is 9. Okay? Inside term, minus 1 times the square root of 3 gives me square root of 3. Outside term, square root of 3 times negative 1 minus square root of 3. Okay? And then negative 1 times negative 1 gives me positive 1. Okay? Square root of 9 is just perfectly 3 minus square root of 3 minus square root of 3 is 2 times the square root of 3 plus 1. Now look what we've done on the bottom. In this case, on the bottom, by doing this trick, we've got this nice perfect number. In this case, when you do this, all you get is junk. You can't do anything with that. So I just wanted to go out of my way to tell you, don't just multiply the top and the bottom by what you see down here. That's not going to do the trick. When you have something like this, what you want to multiply by, I'm going to save you some effort, is almost the same thing. Almost. You change the minus to a plus. Notice this quantity here is still 1 because it's the same thing over itself. But what you will get will be useful. So let's work on the top first. I'm going to put parentheses around here just to make things a little bit more clear. 3 times this quantity is going to be distributed in, so 3 times the square root of 3 is going to be like that, plus 3 times 1 is 3, over. And I'm going to do the same FOIL on this that I did just a minute ago. Square root of 3 times square root of 3, square root of 3 times the square root of 3 is the square root of 3 times 3, which is 9. Okay? For the inside term, minus 1 times the square root of 3, square root of 3. For the outside term, square root of 3 times 1, positive square root of 3. Okay? And then for the last term, it's going to be negative 1 times 1 gives me a minus 1. Now notice the magic of what happens here. These two radicals go away because it's negative square root of 3 plus a positive square root of 3. So in the end, on the top, I'm going to have 3 times the square root of 3 plus 3 over square root of 9 is just simply 3 minus 1. So the answer is 3 root 3 plus 3 over 2. We'll do one more problem just to kind of solidify that. If you have 3 over root 7 plus 2, what I'm going to do is I'm going to multiply, because I've got this root in the bottom, I'm going to multiply both of these things by square root of 7 minus 2 over square root of 7 minus 2. And that's going to do what I want it to do. In the numerator, 3 times root 7 is just simply 3 times root 7. 3 times negative 2 is negative 6 over. And I'm going to do FOIL on this one. Square root of 7 times square root of 7. Square root of 7 times 7 is 49. Okay? The inside term is plus 2 times the square root of 7. The outside term is negative 2 times the square root of 7. Okay? The last term is minus 4, because 2 times negative 2 gives me 4. Negative 4. Now look here. I've got a 2 times the square root of 7 that cancels with this negative 2 times the square root of 7, so I'm on the right track. 3 root 7 minus 6 over square root of 49 is 7, because 7 times 7 gives me 49, minus 4. So 3 square root of 7 minus 6 over 7 minus 4 is 3. Okay? And you can actually simplify this a little bit more if you're clever, because what you will notice is in the numerator, I've got 3 square root of 7 minus 6, and I can factor out a 3 here. I can take a 3 out. On the inside, I'll have a square root of 7 minus 2, and that'll be over 3. And when you think about it, that makes sense, because 3 times root 7 has a 3 in there. 6 has a 3 wrapped up in there. So if I factor that out, I'll get 3 times square root 7 will give me this. 3 times negative 2 will give me negative 6. So this all works out. I can pull the 3 out. Once I can pull the 3 out, I'll notice immediately that on the top I'll have a 3 and on the bottom I'll have a 3. So those things will cancel because 3 divided by 3 is 1. So in the end, your final answer will just be square root of 7 minus 2. And that'll conclude how to multiply and divide radicals in algebra.